screen then?
Yes.
And also, I will give you, when we have 10 minutes, I will give you a warning in the chat window that you have 10 minutes, you have 2 minutes to go.
Okay, sounds great.
So the chat only panelists can see.
Okay. I got that up there now. Okay. Sounds great.
All right, great.
I'm gonna stop my video while everybody else talks in.
Yeah, please do. Yeah, please turn off your video. Appreciate it. Yeah. It's 11:30 and let's get started. All right. Good morning, everyone. Happy Friday to you all. If you're in Pennsylvania, I'm sure you are enjoying this beautiful 55-degree weather, at least in central Pennsylvania, and it's going to be 60s very soon. So please do enjoy and get out and do something fun. So thank you and welcome to session 7E, Innovations for Emergency Responders/AV. My name is Vijay Varadarajan. I work with HNTB, and I will be moderating the session today. Before we move on, let's take care of some few housekeeping items. We have 3 great speakers today. I will introduce them prior to their presentations. Each speaker will have approximately 12 minutes to present their respective topics. At the end of the 3 presentations, we will move on to the question and answer section. We will have approximately 20 minutes for answering your questions. And these speakers are great speakers and they're looking forward to your questions. So please, please get your questions out there and challenge the speakers. We will approximately have 20 minutes for answering your questions. Meanwhile, if you have questions, please feel free to type your questions in the question and answer window as they come to your mind. And also use your chat window nicely. If you want to share some thoughts or if you have any additional ideas on whatever the speaker has said, please feel free to share your thoughts in the chat window. Please note that your phones will be automatically muted during the presentation, and you will not be able to talk. At the end of the presentation of each of the speakers, they have their contact information. So if you do need to reach out to them, please feel free to use the email to reach out to them. So with that, let's get to the topic. So the first topic for today, the way we have set up this section is, we have how can emergency responders do their job better? We are giving some tools in terms of application for responding to the automated vehicles once they are on the roads. So Gabby Benson will be talking about those tools with regards to automated vehicle incident response plan. And then we have some technologies out there on the road which were implemented for helping the emergency responders. And Todd Lees will be talking on those technologies that they have implemented at the Turnpike. Then bring it all. Eric Donald will talk about a PennStart, a facility where this emergency responders can get trained. So this way, we are looking at 3-legged stool for helping emergency responders to do their job better, giving some tools, giving some technologies, and giving training to make their life easier when they respond to incidents. So with that setup, let's go to the first speaker and the first topic. The first topic for today is how to respond to incidents involving automated vehicles, automated vehicle incident response plan. Gabby Benson is going to be talking on the topic. She has experience and strong skill set in traffic management centers, operations, traffic incident management, and emergency management. Benson's experience has been obtained throughout her professional career at the Pennsylvania State Police, PennDOT, and as a consultant. During a time as a project manager for PennDOT Statewide Traffic Management Center, she utilized innovative traffic incident management techniques to ensure safe and efficient travel, developed TMC operations training program, and standard operating procedures. Currently, she works as a TMC operations and incident management specialist for Drive Engineering, supporting PennDOT's Office of Transformational Technology Office in the development of an automated vehicle incident response plan, which she will talk about today. She also works on multiple other projects supporting traffic operations for the Pennsylvania Turnpike Commissions. With that, Gabby, the screen is all yours.
Thank you very much, BJ. Good morning, everybody. I welcome you to the final day of the TESC. Just so everybody has a little heads up, this is not a repeat. I did do a Friday session for TESC last year, but this we're going to look a little bit more at the tools that are available for us that we've been developing from the AVIRP effort. Again, I'm Gabby Benson. I work for Drive Engineering, and I'm here to speak with you all about the Pennsylvania Automated Vehicle Incident Response Plan. I've had the pleasure of working with Mark Kopko and Kevin Tobias for about the past year and a half, 2 years on this project. And we've made some great changes, especially during the COVID period this year. I'll just go ahead and jump into our presentation here. So just really quickly, we're just going to go over a little bit of an overview of the AVIRP itself. We're going to touch on the communication flow chart. And in addition to that, then we'll get into the Pennsylvania AV Incident Response Field Guide, which is an actual mobile application that we are in the process of creating through PennDOT to assist our first responders out on the roadway. So moving into a little bit of the overview, what is an automated vehicle incident response plan? So at its core, an incident response plan is prepared guidance to assist agencies and responders in detection, response, recovery during an incident. So the AVIRP then directly will be focusing on incidents involving automated test vehicles. So for test vehicles in the state of Pennsylvania, that's going to be levels 3s and 4s, as you can see on the right side of your screen there. So the AVIRP will be providing step-by-step guidance and responsibilities from incident detection through investigation and recovery for all different facets of folks interacting with the AV DOT, emergency management, and state police folks. So the AVIRP is going to outline appropriate steps for agency communication as well, some awareness, and will also provide responders with easily accessible incident response tools. So you might be asking, why is this actually needed? So number one, let's start off safety. You know, we're constantly talking about work zone safety, responder safety, and even the safety of our traveling public. You know, these are new vehicles, they react a little bit differently. So we just need to make sure everybody that's dealing with them, that they're as safe as possible while doing so. Communication. So if anybody's familiar with automated technologies, and I presented on this in the past, Tempe, Arizona had an AV crash that they seemingly were unaware of. Basically, the media picked this up before the DOT did. We're just going to try to make sure that PennDOT does not have that happen. So if we have effective communication, we have a strive for reduction in misinformation, or really trying to get as most effective communication flows as possible and promptness with the pertinent information. That's really what we're going to try to lean on to keep the AVIRP moving forward. Additionally, we need to take into consideration incident response. Okay, so these are new vehicles. A lot of folks haven't even seen them before. So how are we going to stabilize these vehicles? You know, in addition to the tried and true tactics that we know for incident management, you know, what can we utilize, or what's different with these vehicles? And we need to make sure that our responders know those things as well. Next, training. So as anybody involved in the DOT realm or transportation traffic realm can understand, you know, there is a definite need for responder training, responder safety, just to make sure everybody is on the same page. And that's really what we're striving to do here. So, you know, with the list on your screen with the AV elements that are listed there, PennDOT and the PennTime Leadership Group, which I'll discuss here in a moment, we actually developed some goals for the Automated Vehicle Incident Response Plan. So number one, we're going to make sure PennDOT is aware of all AV test vehicle reportable incidents, all of them. You know, we need to make sure we're ensuring communications are maintained to assist appropriate response. In addition to that, but interagency coordination efforts as well. And third, we need to make sure that our responders are well equipped with appropriate response considerations and tactics to make sure that we're enhancing safety for these folks. So you see with the elements on the side of your screen there, mainly what we're going to be talking about today is the communication flow chart from bullet point number 1, and then we're going to go into incident response considerations as well, which will lead into a mobile app that we'll be discussing towards the end here. So just a little timeline on what's been going on with the AV side of things. Dating back in 2018, July 2018, PennDOT releases their first AV test guidance. So we have these folks out on the road, they're testing, they need some guidance as far as the DOT side of things is concerned. That gets pushed out. November of 2018, PennTime creates their AV leadership group. Fast forward to February 2019, we have the AV leadership group meeting with the Office of Transformational Technology from PennDOT, which is Mark Kopko's group, and we identify the need for the AV IRP. So moving forward through 2019, we submit a draft framework for the AV IRP in July of 2019. March 2020, right before COVID hit, we submitted a draft communication plan. So what's been going on since then for this realm or for this project is we're beginning to finalize the communication flowchart, which I'll show you on our next slide here. We began writing the draft for the AV IRP, which now is back for additional information to be included as personal delivery devices are moving forward. We're going to have to address those in the IRP itself as well. PennDOT has published new AV test guidance just recently this past fall. In addition to that, we're creating a mobile application for the folks out on the field, the Pennsylvania AV Incident Response Field Guide. So that's in creation right now with PennDOT IT, and we're going to continue moving forward with that effort. Then lastly, moving into 2021, we're hopefully going to be getting into what training and exercise are going to be, or what they're going to look like. Understanding we're still in this COVID state, we're going to try to continue that and keep that moving. And we're going to try to adapt just to make sure we can get these folks trained. So as I said, the communication flowchart, I think, is something that we should at least address before we get into the mobile application or the innovative technology portion of the presentation, because I think it's important to understand the communication process that's going to take place from incident detection through the post-incident activities. So while first responders are out interacting with these automated test vehicles, we have almost simultaneously EMA, state police, and DOT working behind the scenes, communicating information between agencies and stakeholders. Now, there are various methods to these notifications that are going to occur for an AV incidents that are reported. So if you look to the right of the screen on this flow chart, in the red, you'll see the unverified methods of reporting, and then you'll see in the green, those are going to be the verified methods of reporting. And basically all funnel into the STMC. So the STMC is going to act as the clearinghouse, and they're going to be the folks that make sure these communications stay consistent throughout, making sure appropriate folks in the DOT are notified, as well as impacted stakeholders or anybody else that we have engaged in this technology. One thing that we are going to offer based upon our stakeholder meetings is the ability to be notified via email, text, or phone call. And that would be something that, depending upon where these incidents occur, who will get notified. So just to take a little bit of a closer look here, we're going to jump into the AV mobile application, as you can see is one of our verified sources. And this is going to be a tool for the folks that are out on the field actively working with these vehicles. Right, so I will say this is just a mock-up for this point, but this is in production as of right now. PennDOT IT will be working on this and have been working on this for the past several months now. So basically, test vehicles on Pennsylvania roadways are equipped with automated vehicle technologies, right? These typically require enhanced tactics and enhancements to just traditional incident management techniques. So in addition to the new PennDOT AV guidance that requests authorized testers to submit safety information and incident management considerations, we decided, okay, let's take this information, make it usable. How can we get this out in front of the first responders, right? So basically, this is going to be taking place of a typical field guide that folks would be working with when performing any fire or any type of towing exercises or critiques moving forward as far as training is concerned. So we're going to take this information, we're going to put it in a mobile app. That way, this is going to be real-time information folks can access from the field. So the mobile app is going to provide folks the ability to find incident response considerations for all facets of incident management. It's also going to be able to provide a direct way to notify PennDOT that an AV incident has actually occurred. So as we move into what this is going to look like, we're going to start off by, let's just talk about username and password. How do we get into this? So we're going to try to keep this as at least personal as possible. So no personal credentials or anything like that. we're gonna have that responsibility be at the agency end. So let's say Harrisburg City Police Department is our username, and let's say police1234 is the password. Everybody within that department will be given these credentials, and that way they can access that information. Simply type in your license plate information and state identifier for whatever vehicle you're engaging with, and submit continue. And that's how you obtain specific information for that vehicle through this mobile application. Once you submit this information, you're going to go into the following screen. This is going to show you the incident response tools that can be accessed for these folks that are out on the road. So how are we going to secure the vehicle? Something in this module could be anything from how do we disable the self-driving mode to how do we turn off the vehicle, ensuring the vehicle will not self-drive. Are there any like specific things that will just make sure that the vehicle will not self-drive? That's what you can look to expect in those situations or in that specific module itself. Location of documentation. God forbid the human safety driver is not able to produce documents that he or she needs to produce. This is just going to guide the responders and to where the vehicle information actually is, the owner information, registration, insurance, without getting folks that too caught up in the extra instruments and sensors and whatnot that are in the vehicles. Moving into extrication considerations, that these vehicles are equipped with very high voltage devices, self-driving systems, which also have additional electrical considerations, which will pose risks to responders. So let's say somebody is actually stuck in a vehicle, we need to extricate them. This specific module will help folks with some guidance on lifting and cut points, just to stay away from potential additional hazards to make sure everybody's safe in the vehicle. Moving into towing considerations, this is really where we're going to help the towers understand how these vehicles can be towed. Can they be towed like conventional vehicles? In addition to that, how are we going to secure the vehicles to make sure they don't start self-driving if they're in the flatbed truck or however they're being towed, just to make sure folks are safe as well within that module. Moving into firefighting considerations, we're looking at, again, electrification, vehicle fires, we have high voltage systems, we have electrification risks, battery reactions, we have toxic gas emissions that could potentially be coming from these vehicles, and all of those areas will be covered within this specific module. Important to note, I think that folks need to also be concerned with wet conditions, wet environments, how is the vehicle going to react to that considering the high voltage, and additional electrocution risks. And then lastly, we have post-incident considerations. So for this specific section, how are we going to store the vehicle? There's proprietary information, sensors, all that kind of stuff on the vehicles. We don't necessarily want folks to know what's going on inside the vehicle. So do you want that vehicle secured indoors, outdoors? How secure of a location do you need? Ventilation considerations for any potential outgassing buildups, thermal monitoring of batteries, or even accidental contact guidance. So all of these considerations can be found within this mobile app. But I think one of the most, or one of the better things that for my end, knowing that I came from a TMC realm, is the ability to notify PennDOT of this incident actually occurring. Now, the cool thing about this is you're already putting in your vehicle information, so you're already getting this information kicked back. All you simply have to do is click the notify PennDOT button to bring you into the screen that you see here on your slideshow. And all of this information, the AV tester, the vehicle information, license plate, and location of the vehicle will automatically pop up into this mobile application. Simply clicking the send notification will send a notification directly to PennDOT, specifically the STMC, where they can automatically understand, hey, we do have a verified incident. Let's pass this along to the folks in our chain of command to make sure that we are addressing this appropriately. We can get out in front of it and make sure that at least we know everybody is aware the incident's taken place. So that specifically is what we've been working on within the past year. We're going to continue moving forward with that. I really wish I had something a little bit more tangible to show you guys other than just the mock-up, but this is the direction we're going to start going with the AVIRP. So I hope that this meets all expectations, and I thank you for your time. If anybody has any questions, comments, nasty remarks, please feel free to email me, give me a phone call, however you want to do that. But I'll be available for whatever information you guys may need.
Thank you, Gabby. I appreciate it. I'm very excited for this application to come out. It will definitely
I'm extremely excited for it. I can't even tell you.
And the great thing is this is first of its kind in the entire country. So it will put PennDOT in the map too. So I'm very happy about that too.
Yeah, and I think it will also help other facets of the DOT, not just specific AVIRP, but, we can use this same platform to help other folks that are out on the roadways. So I
Thank you.
think we're on a good direction with this. So thank you.
Thank you, Gabby. Thank you. Appreciate it. So moving from the app to the tools, to the technology, Todd Lees is going to talk talk on the second topic. The Todd Lees is the Traffic Incident Management Coordinator in the Traffic Engineering and Operations Department for the Pennsylvania Turnpike Commission. Prior to becoming the PTC TIM Coordinator, he worked as an Operations Center Duty Officer for more than 15 years in the PTC Traffic Operations Center. Prior to his tenure at the Turnpike, he worked as an emergency dispatcher at the Derry Township Police Department and at Lebanon County 911. He is a former volunteer firefighter, emergency medical technician, and hazardous material team member. He is a 2018 graduate of the I-95 Corridor Coalition Senior Leadership Operations Academy, 2019 graduate of the I-95 Corridor Coalition Freight Academy, the 2018 ITS Pennsylvania Person of the Year, the 2019 Cumberland Valley Volunteer Fireman's past President Joseph Bukowski's Responder Safety Award for Highway Safety Award winner, and the 2019 ITS Pennsylvania Project of the Year winner for the Pennsylvania Short 2 Traffic Incident Management e-learning courses. Todd, it's all yours.
Yep, thanks. Can you see my screen okay? Yep, okay. So what I want to talk to you about is saving lives through technology. So we're always looking to see how we can make improvements in our operations and clear the roadway as quickly as possible. In 2020 so far, in the United States, there have been 46 emergency responders that have been struck and killed. So we're trying to change that. We need to make sure that we are always making improvements to get off the roadway as quickly as possible. A little bit about background about the Turnpike, if you're not familiar. 552 miles of total Turnpike miles, about 2,442 lane miles. We operate 24/7, 365, service about 500,000 customers a day. We use the State Farm Safe Patrol program. Those are Turnpike employees driving Turnpike vehicles. We contract with our tow operators. Those are ASPs. We work at a maintenance shed, 23 maintenance sheds, and we respond to about 94,000 calls a year. So it's very important that we use technology to help manage all these incidents that we have. In addition, background information, we have Pennsylvania State Police Troop T, which is 9 barracks, about 200 uniformed troopers that are out there. Our towing companies have a 5-year contract to cover a specific geographical area. And then we also contract, or we pay our fire companies to respond, even if they're volunteer fire companies, and also our ambulances. They get $1,000 a year stipend, and every time they respond to a call, we pay them a small amount. It's not enough to, really, they're not getting rich off of this, but it still gives them a little bit of money and makes them a better partner. The photograph there that we that you see there is doing one of our work zone safety awareness campaigns. We got everybody together and used our drone to try to simulate that you always have somebody at your back on the Turnpike. So if you haven't seen our Traffic Operations Center in Highspire, this is what our TOC looks like. We're making improvements. It covers all 552 miles of roadway from this Traffic Operations Center. The individuals in that front row there are the TOC technicians. They're the ones that are basically like a 911 operator for the Turnpike Commission. They work with the county 911 systems. They answer the emergency calls coming in. They talk to the emergency responders, and they interact with our customers. So they interact in many different ways. We use Waze, we use Twitter, we use Star 11 coming into our operations center and try to get everything communicated as clearly as possible so that we could make things safe as possible. So how are we taking Turnpike to real time as the next step? We use accident photos. We want to be able to share accident photos. That picture says 1,000 words. I want to talk about a little bit about the Star mobile app that we have, how we use mobile cameras, some telematics, the Haas Alert tool, the car tool, the Genetec mobile app, and the push to talk app. So we'll look at those real quickly and talk about how we use all those to work together. So accident photos are very important to us. We want to be able to get a picture of what's going on at the scene. Many times we'll get a 911 call, or we'll get a call from a customer that says, hey, you have a truck that crashed out here. Well, what kind of truck? There's all sorts. Is it a pickup truck? Is it a box truck? Is it a tanker? And did it just bump mirrors? Did it overturn? What's going on with it? So if we get the customer to send us a photo, or one of the responders to send us a photo, that works out great. That allows us to assess the situation, decide if we need to shut down the roadway or detour that as quickly as possible. So we want to get those photographs from our responders. One of the things that we did, we wanted to make sure that we're doing so accurately, is that any photographs that are sent for situational awareness goes to the duty officers in the operations center that we share. If any responder takes a photograph that wants to use it for training or social media, we have a photo policy that I have to be the one that checks the photographs, make sure they're okay. We don't want to have any photographs of a fatal accident, anything showing a victim or any identifying marks or on the vehicle. So we want to try to blur those out. Now, obviously, the bus that you see here for the Department of Transportation is kind of hard to blur that out. That was a crash that we had. They hit the barrier, and we had a number of injuries, 20-some plus injuries that we had transported to the hospital for that. One of the tools that we use for getting information out from the field is sending photos through data capable, which is basically a text alert that we send out to all those people that need to know on the turnpike. When this comes out, it automatically will let you know who that message comes from. We simply type a text message to the 215-515-7073 number. You put the information in there, put where it's at, the main line milepost, and what location, and attach your pictures to and send that. That automatically will go to those that need to know's text messages, which is a great help for us. In addition, our IT department helped develop the STAR app. STAR app is situational awareness, traffic awareness tool. We get notification on that, so it comes up as a app on your phone. Tells you, it works off of Android or iPhones. Tells you accident details, gives you the live incident map through our CAD system or computer aided dispatch system, and then also gives you a map of where the incident occurs so that you can see that. We developed this because we wanted to make sure that we have good situational awareness. A little bit closer look for that is it gives you the information in, works off your cell phone and works off works off the app, like I said. So it gives you a little bit of disabled vehicle blocked in the left lane, gives you the basic information, tells you what emergency equipment responds. So for a disabled vehicle like that, that's flat tire, good spare, AAA customer, it gets the Pennsylvania State Police, it gets our maintenance, and it gets our tow truck to go out to that. This is what it shows up in the box. So you could click on any of these links there from the assist agency, the roadway obstructions. Those are color coded. So anything in red is the high priority calls, yellow is the intermediate calls, and green is not really a high priority call. Those are more informational. But we also have it linked to a map that we could do. We could bring that in, and you could even go in there to a road view showing you what the roadway characteristics look there. So that worked out quite well for us. We rely heavily on mobile cameras, so all of our State Farm vehicles have mobile cameras installed in them. Full pan tilt zoom, they're available 24 hours a day, 7 days a week. So when the State Farm Patrol, again, who are turnpike workers driving turnpike vehicles, are responding to an incident, we want them to be close to the scene so we can control that camera and see what's going on, so that the people that are on call from our traffic operations or traffic engineering can see what's going on and also share that with maintenance. So the traffic operations center controls the cameras. The person in the truck cannot control that camera at all. They are hardwired into the truck, and that way the traffic operations center could control that live video going back to them. This is an example here of some of the video here. Again, the camera's dirty. We ask them to clean them usually once a shift, but obviously during the summertime, you get that. So that's our traffic operations center turning the camera around there. Normally when you're driving, it's not going to be turning around like that, but we just wanted to show you some of the video. And again, if the camera screen's cleaned a little bit better, you get a much better picture. Telematics, we use telematics in our vehicles, again, to see where they're at. PennDOT uses this as well. We have 523 maintenance vehicles equipped. We use a Verizon Connect Tech software. It helps develop situational awareness. We know where our vehicles are at. We know when our vehicles are in a plow train or a snow train, and we assist in monitoring the backlog. So these are in our State Farm vehicles, our Foreman vehicles, and our dump trucks as well. And we can see right where they're at on the map. We also use Haas alert devices in our vehicle. Haas is a great partner for us. What this is a app or it's a device that goes in your vehicle. I have one in my Turnpike vehicle, so that wherever we're at, if I activate my emergency lights in my vehicle, within 20 seconds, it puts a message up on Waze letting them know where I'm at along the side of the roadway and tells them to slow down, move over. That's important for us because we want to make sure that we are, seen at the scene. We had 46 responders struck and killed in the United States in 2020. We had 44 killed in 2019. In Pennsylvania, we've had 151 emergency responders killed all time, not counting the PennDOT and Turnpike workers. We had a serious injury to a Turnpike worker, not this past Monday, but the Monday before that, that could have been fatal. So we want to protect them at all costs. Turnpike currently has 98 vehicles equipped with a Haas alert, and we have another 44 devices now that are available as a plug and play device to put in some of our TMA trucks. This gives an example here of how Haas works. It tells you where the roadway hazard is. It will tell you where the unit is coming up there. So that's Somerset. As I was driving back from Pittsburgh this week, our one of our maintenance workers was able to say right where I was at, my speed. So it is a little bit of Big Brother watching, but at least we know that somebody's watching and knows where we're at, which to me is a good thing. Since we've been using these since the beginning of the year, we've alerted about 1.4 million customers that we are out there along the roadway, which is again a good thing. It currently works for Waze. We're working to get them to work with Google Maps as well. Once we get in Google Maps, I think that's a great thing for us as well.
We have seen over the last few years tremendous growth in the amount of information we can get from a variety of sources, whether it's traffic information, real time, weather information is being more refined, volumes and other information about how traffic flows on the system are getting more robust, but we weren't able to combine it into a way that really helped us operate.
The CAR program is catch it early, act, analyze, and review. And it's been helpful for us. It's reduced our time on the roadway, and it's got our customers moving faster. So we have a lot of different data. We have data coming in every 30 seconds. We have data coming in every 2 minutes. We have Waze data coming in. We have speed data coming in. We also have weather data coming in. So the start of CAR was, let's gather all this information that comes from multiple sources and crowdsourcing and put it into an application. We actually divide all of that information up into half-mile segments. So every 2 minutes, the early warning detection tool actually reaches out to Waze, reaches out to Interx, and reaches out to weather, and gets that half-mile segment of what's happening in the half-mile segment. So it gives the duty officer a way of looking at that half-mile segment every 2 minutes to see what's happening on the roadway.
In terms of the volumes of data that we are processing and working on a daily basis, it's vast amounts of data that is fed right through for visualization, for best situation awareness of what's going on, as well as being collected for analysis of it on the back end as well for trends.
We can actually go on here, and if we see an incident and it shows that there's a slowdown in a specific area, then what we can do is we can click on that incident, pull it up, and see exactly what's going on. And by utilizing that one system that pulls resources from different programs, it gives us a better view of what's going on out there on the roadway.
The catch it early piece of it is, to catch it early, we use an early warning detection tool, which kind of brings third party and crowdsourcing together and gives an overall picture of each half-mile segment of the roadway. And the ACT piece of it is a TIMS viewer, which is our GIS application. And that gives us a good overall view of who's there, who needs to respond, what's happening at the scene, and what the backlog is at the actual scene. The after action review is afterwards we get together and we have to understand how we responded, could we respond differently, how we could do things better.
Our biggest challenge is keeping an eye on the 552 miles of roadway that anything can happen on at any time.
Our duty officers have about eight or nine different screens they actually monitor, about 15 to 18 different applications they actually have to go through. And that could be from social media to the CAD system to our new ATMS system, which controls the signs and helps with traffic, and just multiple things. Twitter, they look at just different stuff that they need to look at in order to monitor roadway, and they look at the cameras that we have on the roadway and monitor the speeds. So they have multiple different applications they need to look at, and once they respond or start to respond to an incident, they have to do multiple things: call people, make sure that everybody's dispatched to the actual scene, make sure everybody's safe, and make sure that, that we're doing the right things at the right time.
Okay, finally, then Genetec mobile app, we use our cameras, so we're able to bring them up on a cell phone. We use the Genetec mobile app. We could pan, tilt, zoom. We could play back any of the videos on our cameras. So any of our people that have access to the system that are authorized to use this could bring up any of the cameras anywhere. It works out great if we're on call, so that we're able to maintain situational awareness on whether we need to keep the roadway open or shut the roadway down. Finally, the final thing I wanted to show you is the InstaConnect system that we use. We use AT&T push to talk, so that we're able to use our phones as a radio. So I could talk to any of our radio units across the Turnpike system. Doesn't matter if I'm not even on the system. I'm able to talk right to the units in the field and maintain some situational awareness that way. So I appreciate the time. If you have any questions about anything I went over, I know I went over very quickly, feel free to reach out to me as well. There's my contact information. And thank you, VJ, for allowing me to speak.
Thank you so much, Todd. Appreciate it. It's very interesting to see how the Turnpike is using a lot of technologies to help with TIM. So let's move on to the last speaker for this session, but not the least. The session topic is the topic of the particular item is saving lives through training, PennSTART status update. Eric is going to talk on this topic. Dr. Eric Donald is a professor in the Department of Civil and Environmental Engineering at the Penn State, director of the Thompson D. Larson, Pennsylvania Transportation Institute, and director of the Center for Integrated Asset Management for Multimodal Transportation Infrastructure Systems. He has 21 years of teaching and research experience related to geometric design of highways and streets, speed management, and traffic safety. He has served as principal or co-principal investigator on research projects from sponsors including the National Cooperative Highway Research Program, Federal Highway Administration, PennDOT, National Institute of Occupational Safety and Health, New York City DOT, Montana DOT, and Department of Defense. Dr. Donald has published more than 100 peer-reviewed journal articles and technical research reports. He currently chairs the Transportation Research Board's design section and is past chair of the TRB's Geometric Design Committee. He is an associate editor of the Accident Analysis and Prevention Journal, as well as associate editor for the Transportation Letters International Journal. He also serves as a member of the FHWA PennDOT Statewide Transportation Innovation Council and is a member of the Governor's Highly Automated Vehicle Advisory Committee. Dr. Donald is a past leadership fellow of the ENO Foundation. With that, Eric.
Thank you, VJ, for the nice introduction, and Gabby and Todd for your excellent presentations. Thanks for the opportunity to join you here on the final day of the conference. I will give an update on the status of the PennSTART project, trying to focus some of the discussion certainly on the training elements and the opportunities associated with training here at the facility, to try to help tie together some of the great remarks you heard from Gabby and Todd. So start off with a quick update. What is PennSTART? The Pennsylvania Safety, Transportation, and Research Track. It's a state-of-the-art training and testing facility. The need for the facility, I think, sort of is twofold. The first one is that about 80% of emergency responders in the state of Pennsylvania have not received any kind of formal training in response to incidents. This would afford an opportunity with a facility of this magnitude and size to do training out on a closed loop facility where it's safe. And it would replace some of the desktop exercises and the computer-based exercises that currently exist as training opportunities for this stakeholder group. A second opportunity or need for the facility is to test transformational technologies in a controlled environment in this closed loop type of a facility. Our efforts are focused in 6 key areas with this concept: traffic incident management. The training components of that, of course, I think are very, very key, and they're part of the critical need for the facility. Connected and autonomous vehicles, tolling. You'll see some concepts associated with tolling, ITS, traffic signal control in the concept design. Work zone traffic control, commercial and transit vehicles. In terms of the project, here's a quick overview of the timeline, and I'll try to spend a little bit of time on each of these 5 or 6 pieces as we go through the presentation. I do want to note that a lot of documentation associated with each of these steps in the project timeline can be found on the Penn Start website. The web address is at the bottom of this slide, www.pennstart.org. So we started with this process and this study. I think Joe Suter and Troy Truax from Michael Baker visited with us a couple of years ago at Penn State and saw our current test track operation there. And we started having a lot of good conversations about, the feasibility of something that's, a bit more robust than our 1 mile closed loop oval that we currently have. And that led to this feasibility study in defining the need for the state-of-the-art facility and what the benefits would be here within the region, primarily in Pennsylvania and beyond. That particular effort was finished in August 2018. We then followed along in the systems engineering process to a concept of operations where we defined the vision for the facility, and that document was prepared and made available in February 2019. We moved into a systems requirements document where we defined the specifications and how to integrate all the various components to build this system, which is the overall facility. That process was finished in December 2019. We then moved into a business planning document to define the user needs, design, construction, operational costs associated with the facility. So we defined capital cost of construction, operations, and maintenance costs, developed a business model, and that particular effort was finished as well in December 19. And we've since moved on to a market analysis where we looked at various business models and how do we provide for the operations and maintenance costs associated with a facility once it is opened. That effort was finished in 2020, and we have some ongoing efforts that I'll describe here in just a couple of minutes. In terms of the feasibility study, this was the concept design, about a 1 3/4 mile oval, 110-acre site. You can see the various components. You have a multi-lane, closed loop, high-speed oval, plenty of intersections, a roundabout, signalized intersections, unsignalized intersections. A loop is in the lower right-hand corner here. You have merge diverge areas on a multi-lane sort of freeway look-alike on the lower portion. The tolling gantries, heliports, parking spaces, truck turnaround area, highway rail grade crossing facilities as well. So a lot of different transportation facilities and components built into the overall concept or the system. That was kind of the feasibility study. In terms of the concept of operations, when we were starting to think about, what kinds of facilities could we have here and the usage that we could accommodate. So we looked at the concept sort of as a baseline and what opportunities existed for some additional elements or features to be added to this. So we defined opportunities, the rationale for some of those opportunities, what the implications on the overall cost of the facility would be, and what a possible solution was. Facility expansion, and that comes with land-related impacts. Speeds, one of the things we've talked about in terms of a solution to increase or maintain high speeds in the curves on the facility is to increase the banking or the super elevation in the curves. We talked about a tunnel section, particularly in a secondary phase where we could do some kind of above ground tunnel formulation. And that would basically be able to kind of reduce the communications and test the quality of communications at the facility. We talked about a longer bridge structure, enhanced weather simulators in kind of a second phase as well. So we had a lot of great discussion about the concept of the operations, definition of the use cases and the possible users and the stakeholders. We then moved into the system requirements phase where we defined various facilities and the cases that could be supported and the infrastructure and the systems that we needed to combine to create this concept. And these are just some examples of the various requirements in the facilities that we have planned into the concept. Here is another graphic listing a variety of features, including infrastructure pieces, as well as the communication pieces you'll see sort of in that third row of the blue colored part of the graphic. And all of those would be a first phase of development. A second phase through this ConOps and systems requirements, planning processes and documentation effort, we talked about future phases, like a second phase where we would have an academic building, this tunnel section, the weather simulator, and provide for some space for an aircraft training simulator as well to make this a very multimodal facility. So the business plan, there are 4 basic sections of the business plan, including the market needs in terms of how all 3 of these sectors could use the facility, including public sector, private sector, as well as the research and educational institutions. A competition analysis, we visited several other facilities. When we put together this plan and the market analysis, we considered proximity of other facilities as well when we were preparing this. There's then a business model, which I'll talk about in terms of having the operations and maintenance resources to operate the facility into the future. And then an implementation strategy, who is responsible for the design, the construction operations of the facility, and who's responsible for maintaining these relationships and building these partnerships between the public, the private, and the research sectors. So in terms of the market, there are several elements that came from this particular effort, the business plan, market analysis, and one is innovation. We think, and what we're really most excited about is the opportunity for all 3 of these stakeholder groups, these general stakeholder groups, to come together and produce innovation, whether it's in autonomous or connected vehicles, whether it's an opportunity to innovate through training and outreach and technology transfer. I mean, this is a place that's closed loop, and we have an opportunity for our emergency responders to, try as best they can to mimic what they may encounter in a real incident in this closed loop and a bit safer environment. So we've got these 3 sectors coming together: the private sector with R&D and testing, the public sector, they're interested in testing and training and policy development, academic research, and the educational opportunities and technology transfer opportunities associated with that. So there's this innovation where these 3 sectors come together to build on sort of the state of the practice in transportation. Another benefit associated with this is just access to research, education, all in one location, as well as technology transfer. We could test a lot of different scenarios. We've got 4 seasons of weather here in central Pennsylvania, and so we've got opportunities to look at some cases in different weather. This is a private, secure environment. There's space for storage at the facility. So those are some great benefits through the market analysis that were defined. A whole series of additional benefits in terms of its centralized location in Pennsylvania, its accessibility in central Pennsylvania. Customizable configurations were defined in the systems engineering and concept of operations documents. This ability to collaborate with researchers to gain insights into the future and produce the state of the art here in Pennsylvania to better understand, these different market sectors. Sharing of data as it's collected at the facility is another, I think, very valuable benefit for the industry. And then this infrastructure to support a lot of different activities, including training, as well as tech transfer activities and testing activities. So at this point, we've kind of moved into an outreach activity where the business planning, the market analysis, the systems engineering process has kind of taken, has progressed through. We've learned there's considerable interest in the facility in Pennsylvania. We're now talking with candidate private sector collaborators about potential sponsorship opportunities. We really truly believe this is just an outstanding concept and certainly can support training for the traffic incident management industry. And we also think it can support that other need, which is the need for testing of emerging technologies. Really great quote here from a KPMG recent report on investment in autonomous, connected, and electric vehicles, sort of the three pillars of this major movement that's happening in the transportation sector. The investment could be up to $345 billion over the course of the next 5 years. So we feel that there's a strong market for this here in Pennsylvania. Our next steps in the project are that we're working on a memorandum of understanding between PennDOT, the Turnpike Commission, and the university. We're continuing this market outreach activity, talking with that private sector. So that's sort of the third spoke of this wheel, or the third piece of the stool, with the public sector and the university working together, bringing in that private sector for the training and the emerging technology research, development, testing opportunity. We're refining the concept and our cost estimate for the PennStar facility. And we're also thinking of ways where we can connect this PennStar facility to an I-99 connected corridor concept. So you've got this closed loop facility at PennStar, safe, consider a variety of testing scenarios. And how do you scale that up to a real road test or real road training? So we're starting to think about that, and the facility being located in central Pennsylvania near Interstate 99. We're starting to plan for and consider some concepts there. We're updating our schedule for design and construction. And then our plan is once we've got that schedule complete and a few touch points with the various partners finished, we then move into design and start to procure some of the other support services necessary for the facility development. So Vijay, again, thanks a lot for the opportunity to join the group here. That concludes my presentation.
Thank you so much, Eric. Appreciate it. It's a very nice presentation, Eric. We have 10 minutes approximately to go into Q&A session. So we have only one question on the Q&A platform, and I have a few questions for the speakers. So with that, the one question we have is for Gabby. Gabby, it seems like the AVR IRP is open to all, as there's not individual username and password. But can be a whole organization? Is there a concern with public access to the instant information? If not, why have the log on?
Okay, so there's a few reasons for this. One, there is a concern that folks are just going to get in and start running license plate numbers and try to get something to come back. With the proprietary information for the automated test vehicles and their manufacturers, we're trying to keep that as much out of the public eye as humanly possible. They submit this information to PennDOT. I can't even view the information before it goes into the application due to legal reasons. So we're trying to keep that, at least on that end of things, tied away from anybody from the public to be able to access that. In addition to that, the organizational point for your username password, it's going to put the ownership back on the organization. So on the back end of this app, which I did not mention, anytime any of these license plates are submitted into the mobile app, we're going to get flagged. So we're at least going to be able to pay attention who's running what, just to make sure that we're not out here just trying to access whatever information we can get. And so we're going to put that responsibility back on the organization just to make sure nobody's abusing the system itself. The way we are hoping that this is going to run is folks are going to look up the license plate information, get the information back for the incident itself, and then we are going to be notified for the crash directly after. I toss around ideas about training and whatnot to be able to look at things that way. If we could have just some, just standard cases or vehicles that we could put in there that we could actually show to the public. But that, again, still in development with that. Mainly proprietary information. We just want to make sure that the testers feel safe with who's actually receiving their information.
Thank you, Gabby. Since you are on call, I have one question for you. What is the timeline we are looking at in terms of when we will be able to finish the app, and when will the emergency responders able to get the training?
Sure. So We're actually working on all of this all together at this point. So the AVIRP draft itself has been submitted to PennDOT. We have to throw some additional information in there for the personal delivery devices. So that's going to slow that portion of things up. The mobile application, we had started talking to IT over the summer, like late summer, beginning of fall. So that's still sometime 2021, we're going to be able to roll that out. But mainly with the training and exercise, that's going to be our next step. As soon as the draft is finalized for publication, then we're going to jump into the training. So we're really shooting for first quarter of 2021 to get some training and some of that stuff out in front of some folks. Again, we understand the COVID implications and restrictions that we have going on, but we're at least going to try to get something, even if it's just virtual, so we can have some testers even involved for these folks to get some of their questions asked and answered.
Thank you, Gabby. And Todd, I have a two-part question for you, which is, which one of these technologies you talked about are used mostly or commonly? And are you working on any other future technologies for the emergency responders or incident management?
Yeah, we're always looking on ways to adapt. I think probably the biggest thing we're using is the CAR program, the Catch It Early, because we want to see what's on the roadway, as soon as possible to get going. So we've shrank our incident timeline from about an hour and 47 minutes to an hour and 18 minutes at the Turnpike because of what we're doing. We're not satisfied with that, so we're always looking to make improvements. So one of the things that we find out is we get information from Waze and Indrix probably 6 minutes faster than we get it from 911. We start seeing something's out there. So knowing that, we're going to start trying to dispatch based off that information and get somebody heading that direction before. Why wait if you already know something's out there or suspect something's out there? You could always turn them around. You can't, unring that bell if you wait. So I think that's a key for us. I think having building the partnerships with our consultants, with our engineers and everything, they come up with great ideas. So don't be afraid to share those ideas. So I think having that makes it absolutely important to us. Going forward, I think just some technologies on how to clear the roadway quicker. One of the things we're doing is we call it the Debris X tool, which basically goes on the front of some of our vehicles that instead of our people getting out of the vehicle to clear that tire off the roadway or something that's on the roadway, they could just basically work with a little joystick in the cab of their truck, and they could steer it off to the side of the roadway and saves them from being a target on the roadway. So Eric, once PennStar opens up, that stuff that we could test up there on a track like that in real world environments and be able to do that to work together. So we're always looking for the next great thing. We're not afraid to steal from other states or other agencies. If they come with an idea, we liberally borrow stuff from them. But it should be the severest form of flattery. The AVIRP thing that we're doing is going to help us as well. It builds a stronger team for us.
Thank you. Great answer, Todd. I appreciate it. I'm looking forward to those two. Whatever it takes to improve the safety of the emergency responders, right? Eric, I have two questions for you too. The first question is, are you aware of any other similar facility doing something similar to what you're doing at PennStar?
I would say in terms of the combined focus of PennStar with the emergency responders and the traffic incident management and the combination of testing, research development for emerging technologies, no. I think there are a number of facilities around the country who focus on one or the other, but not both. So that's what's so exciting in working with PennDOT and the Turnpike Commission on this particular project. And I was remiss in not mentioning Mark Kopko and Joe Suter from PennDOT and the Turnpike and their collaboration. It's been a great collaboration so far and working with their teams.
The second question for you, Eric, is, the facility is going to be most likely in Penn State, right? And the responders are spread all around the country. Do you think they'll be willing to travel to Penn State to get the training?
I think so. I mean, I think this is a very central location in the Commonwealth of Pennsylvania. I think through the feasibility study, the team who did the feasibility study looked at a 2-hour radius around State College as well as a 4-hour radius around State College, and you capture quite a bit of the Mid-Atlantic population. I mean, you gather in Washington, D.C., Baltimore, Philadelphia, Pittsburgh, Cleveland, New York. So it's, we're very centrally located among a lot of very urbanized places. So I think they would be willing to travel here. And I think, this region and the facility, the concept itself just has so many unique features and opportunities for, the emergency responders to learn, at a physical location. I think Todd's mentioned the desktop exercises and the computer exercises, and they're great. But this gives you a chance in a closed loop environment to, kind of see things and learn how to maybe handle the response to an incident.
Yeah, and I know even nationally, people want to come to this whenever it opens. I've had contacts in California, Colorado say, when you get it open, let us know. We'll come there. We want to see what you're doing and learn, because again, it doesn't happen anywhere else in this country right now.
Yeah, that's great. And the other component I didn't really spend a lot of time mentioning was the space for the aircraft firefighter rescue. We actually saw that training taking place when we were visiting with the University Park Airport. And we learned there's a great need for that type of training throughout the country. And there would be people from all over the place that would travel here for that type of training as well. So a lot of different modes, I think, can be considered in the concept, which I think is also something very unique about it, and it's another major benefit.
Thank you all. It's 12:30 on the dot. Thank you all the speakers. Great presentation, and we're all looking forward to what's out there in the future for us, for our community as a whole. And I'm sure we will get more updates over the next few years, because this is not once and done thing, any of the things that you talked about. So, we are looking forward to hearing from you again next year on these topics. So with that, thank you all for the speakers and also the participants. Have a very good day. Take care.
Thank you all.
Thank you, guys.
Yep.
Bye.
Take care.